Hi, Assalamu alaikum. My name is Nazif, and today me and my groupmates will be presenting about conic sections. So, what is a conic section? Conic sections are basically any curve produced by the intersection of a plane and a right circular cone. Now, depending on the angle of that intersection, you might get four different shapes, which are circle, ellipse, hyperbola, and parabola. Now, this is a diagram to more visually represent what I just said. But as you can see, for let's say for circle, when you intersect a cone and a plane perpendicularly to each other, you get the circle shape. And if you adjust that angle, you get all the other three shapes. Now, here are some real life applications for all the shapes I just talked about. Ellipses are used in astronomy to describe planetary orbits. So as you know, planetary orbits are in the shape of ellipses. And parabolas are employed in satellite dish designs for focusing signals. As you can see, the shape of this satellite dish is in the shape of a parabola. And finally, hyperbolas find applications in navigation systems, for example, GPS. In this diagram, we can see that the intersection of two hyperbolas give you an accurate location for the receiver. Alright, that's all from me. I pass to my friend Danish.
Alright, Assalamualaikum and good afternoon to everyone. My name is Danish Iskan, and today I'll be answering the questions on applications of conic section in life. And so for our first problem, it is regarding parabola. And the question states that a bridge has a parabolic arch that is 10 meters high in the center and 30 meters wide at the bottom. Find the height of the arch 6 meters from the center on either side. So we have the diagram down here, and what they actually want from these questions is the height from D to E, which is 6 meters away from the center. And in order to find the answer for these questions, first of all, we need to know the equation. And these are the equations for parabola. And from the graph, we can see that it is opening downwards. So the equations for a graph that's opening downwards is x squared equals to negative 4py. And over here, these are all the equations. These are all the formulas that you can use to answer parabola questions. So since we've identified the equations of parabola for these questions, which is x squared equals to negative 4py, we can substitute point B, which is right here. This is the x-axis for this is 15, while the y is negative 10 since it is below the x-axis. So we'll just put in 15 squared equals to negative 4p times negative 10. So in the end, we'll end up with 4p equals to 15 squared over 10. So the main reason we're really doing this right here is to find the value of 4p. So once we found the value of 4p, we can use 4p and substitute point E into the equation, so we can find the value of negative y. So then we'll end up with 6 squared equals to negative 15 over 10 squared times negative y. So in the end, we'll get y equals to 8 over 5, or 1.6 meters. So this 1.6 meters is actually referring to the point of x-axis towards E. So from x-axis towards E, that is 1.6 meters. So in order to find the distance from point D to point E, so we'll just have to take 10 meters minus with the 1.6 meters we got, and we'll end up with 8.4 meters. So 8.4 meters is actually referring to the point of D to E. So that is the answer for this question. Alright, so now moving on to the next question, we have a ellipse question. The question states that a tunnel through a mountain for a 4-lane highway is to have an elliptical opening. The total width of the highway is to be 60 meters, and the height at the edge of the road must be sufficient for a truck 4 meters high to clear. If the highest point of the opening is to be 5 meters, how wide must the opening be? Alright, so first of all, the total width of the highway, which is 60 meters, is referring from point A to point B, 60 meters. And we can divide this into two sections. So that will be A to origin and origin to B, which is 8 meters each. Next, the edge of the road must be sufficient for a truck 4 meters high to clear, and that is referring from point D to point E and from D node to E node. So that is 4 meters for both of them, and the highest point of the opening is 5 meters. This is referring from origin to C, which is 5 meters. Okay, so first of all, to answer these questions, we need to know the equations for this question. And the equation for a ellipse is x squared over a squared plus y squared over b squared equals to 1. And then there are different options down here where if a is bigger than b or if b is bigger than a. And you can use these formulas for ellipse questions. Okay, so moving on. So we've gotten the equation of ellipse, which is x squared over a squared plus y squared over b squared equals to 1. So the main question here is what is A and what is B. So A is actually the length of semi-major axis. So on the diagram, the semi-major axis is either origin to A or origin to B. So it's technically just half a major axis. So the semi-major axis is 8 meters, and A is referring to the semi-minor axis, which is from origin to C, which is 5 meters. So we can just substitute A and B, and it will end up with x squared over 64 plus y squared over 25 equals to 1. So then once we've gotten that, we can just substitute the value of y equals to 4 meters, which is at point E actually, 4 meters. So we're trying to find the value of the x-axis, so we just substitute y as 4 meters. So then we'll end up with x squared over 64 plus 4 squared over 25 equals to 1. So we just move the 4 squared over 25 to the right hand side. So then we'll get x squared over 64 equals to 9 over 25. So 64 and move it to the right side and then add a square root because it's x squared. So then we'll get x equals to square root of 64 times 9 over 25. So in the end, we'll end up with x equals to 4.8, which is not the answer. The 4.8 meters is referring from origin to point D. So what we actually want is D to D node. So since we got the length of origin to point D is equal to 4.8 meters. So to find from D to D node, we just have to times that by 2 and we'll end up with 9.8 meters, which is the answer for these questions.
Okay, so to sum up, conic sections are fundamental geometric shapes derived from slicing a cone at various angles. These shapes include circles, ellipses, parabolas and hyperbolas, each within unique properties. Practical applications range from astronomy, which uses elliptical orbits, to engineering that uses parabolic reflectors.